Chapter 5 Elasticity. Chapter Objectives 1. Use price elasticity of demand to analyze the effects of change in price on quantity demanded. 2. Identify factors that influence the price elasticity of demand. 3. Explain the relationship between elasticity, the demand curve, and the total revenue. 4. Use other elasticity measures to classify goods or pairs of goods as normal, inferior, substitutes, or complements. 5. Use price elasticity of supply to analyze the effects of a change in price of a quantity supplied. 6. Explain how price elasticities of demand and supply impact tax indulgences. Elasticity concerns how sensitive changes in one variable are to change in another. The price elasticity of demand, for example, measures how sensitive changes in the quantity demanded are to changes in the price. That is, what happens to sales if a company raises the price of its product. We know from the law of demand that quantity will decrease, but the price elasticity of demand measures how much quantity will decrease. If sales only fall a little, then the overall total revenue the firm receives from selling the product will rise. However, if the sales fall a lot, then the overall total revenue from the firm receives at selling the product will fail. This chapter first teaches you how to calculate the percentage change in the quantity demanded that results when the price changes by the given percentage. Then you'll see how this relates to the total revenue. You will also see how changes in the price impact the quantity supplied. Finally, you'll see how changes in consumer income and the prices of related goods affect percentage changes in the quantity demanded. 5-1 Price elasticity of demand. In Chapter 3, when we studied this demand curve, the focus was on the law of demand, which states that there is an inverse relationship between the price and the quantity demanded of a good or service. In this chapter, the emphasis is on measuring by how much of the quantity demanded changes the price when the price changes. Price elasticity of demand explains how strongly consumers react to a change in price. If you think of the quantity demanded as a rubber band, then the price elasticity of demand measures of how stretchy the rubber band is when the price changes. 5-1a Calculating the price elasticity of demand. Economists use the price elasticity of demand formula to measure the degree of consumer responsiveness or sensitivity to a change in price. Price elasticity of demand is the ratio of the percentage change in the quantity demanded of a product to the percentage change in its price. The elasticity formula is ED equals to percentage change in quantity demanded over percentage change in price, where ED is elasticity coefficient that measures the degree of elasticity. Suppose a university enrollment drops by 20% because tuition rises by 10%. The price elasticity of demand is calculated as negative 20% over 10%, which is 2. The elasticity coefficient of 2 means that the quantity demanded enrollment changes 2% for each 1% change in price tuition. Note that there is a minus sign before the 2, but economists drop the minus sign because we know from the law of demand that the quantity demanded and the price are inversely related. This elasticity formula can be expanded to create what economists refer to as the midpoints formula, also sometimes referred to as the arc elasticity formula. To do this, we need to first think about what percentage changes. Suppose temperature increases from 40 degrees to 60 degrees, and you want to calculate the percentage change in temperature. Percentage change in temperature would typically be calculated as a change in temperature divided by the original base temperature times 100, or 60 minus 40 over 40, all times 100, which will equal 50%. Notice that this answer would be different if the temperature decreases from 60 to 40 degrees. So it would be 40 minus 60 all over 60, which is all times 100, which would be negative 33%. When working with elasticity, economists are focused on changes between two possible base points, so they use the midpoint or average of those points rather than the base point. The elasticity formula can therefore be expanded as follows. ED equals to the percentage change of quantity demanded all over percentage change in price. And when simplified, it becomes ED over Q2 minus Q1 divided by Q1 plus Q2. And that all over P2 minus P1 divided by P1 plus P2. Where Q1 represents the first quantity demanded, Q2 represents the second quantity demanded, and P1 and P2 are the first and second prices. Note that because we are finding averages, it does not matter which is first or the second number. Now, suppose you're the manager of Steel Porcupine's Rock Group. At $25 per ticket, you would sell 20,000 tickets. If you raise the price to $30 per ticket, only 10,000 tickets will be sold. We can use the midpoint formula to calculate the price of electricity as follows. The value of 3.7 tells us that for every 1% change in the price of Steel and Porcupine's tickets, the quantity demanded will change in the opposite direction by 3.7%. Take note, the price elasticity of demand is the percentage change in the quantity demanded divided by the percentage change in price. The midpoints formula for calculating the price elasticity of demand is as follows. Am I on track? 1. Susie Sandwiches raises the price of sandwich from $5 to $6, and those sales fall from 220 sandwiches sold each week to 180 sandwiches sold each week. The price elasticity of demand for sandwiches is A. 0.5, B. 0.9, C. 1.1, or D. 4. 1-5-1b. Classifying the price elasticity of demand using the total revenue test. As reflected in the midpoints formula, the responsiveness of quantity demanded to a change in price determines the value of elasticity coefficient. There are three possibilities. 1. The numerator is greater than the denominator. 2. The numerator is less than the denominator. And 3. The numerator equals the denominator. Exhibit 1 presents three cases that the Steel Porcupine's Rock Band may confront. Exhibit 1. The impact of a decrease in price on total revenue. These three different demand curves graphs show the relationship between a decrease in concert ticket price and the change in total revenue. In Part A, the demand curve is elastic between points A and B. The percentage change in quantity demanded is greater than percentage change in price. ED is greater than 1. As tickets price falls from $30 to $20, there's a large increase in the quantity demanded from 10,000 to 30,000. So the total revenue increases from 300,000 to 600,000. And Part B shows a case in which the demand curve is inelastic between points C and D. The percentage change in the quantity demanded is less than the percentage change in price. ED is less than 1. As the ticket price decreases from $30 to $20, the quantity demanded only increases from 20,000 to 25,000. So the total revenue falls from 600,000 to 500,000. Part G shows a unity elastic demand curve. The percentage change in the quantity demanded equals the percentage change in price between points E and F. ED equals 1. As ticket prices decrease from $30 to $20, the quantity demanded increases from 20,000 to 30,000, and total revenue remains unchanged at 600,000. Elastic demand. Suppose the Steel Porcupine's demand curve is predicted in Exhibit 1A. If the group lowers its ticket price from $30 to $20, the quantity demanded increases from 10,000 to 30,000. Using the midpoints formula, we obtain a value for the price of elasticity demand of 2.5. And this means, for example, that 20% reduction in ticket price brings a 50% increase to the quantity demanded. Whenever ED is greater than 1, like ED equals 2.5, we say that the demand is elastic. Elastic demand is a condition in which the percentage change in the quantity demanded is greater than percentage change in price. Because percentage change in the quantity demanded is greater than percentage change in price, the increased sales overweigh the drop in price, and the total revenue increases. Total revenue is the total number of dollars a firm earns from the sale of a good or service, which is equal to its price multiplied by the quantity demanded. Perhaps the simplest way to tell whether the demand is elastic, unitary elastic, or inelastic is to observe the response of the total revenue as the price of product changes. For example, in Exhibit 1A, the total revenue is at $30 is 300,000. the total revenue at $20 is $600,000. Compare the shaded rectangles underneath the demand curve, representing the total revenue at each price. The gray area is the amount of revenue unaffected by price change. Noted that the green shaded area gained $20 per ticket is greater than the red shaded area lost at $30 per ticket. This net gain of $30,000 causes the total revenue to increase by this amount when the steel porcupines lowers the ticket price from $30 to $20. Inelastic demand. The demand curve in Exhibit 1B is inelastic. The quantity demanded is less responsive to the change in price. Here, a fall in ticket price from $30 to $20 causes the quantity demanded to increase just by 5,000 tickets. Using the Midpoints formula, ED equals 0.55. This means that every 1% change in the price, there's only 55% change in the quantity demanded. For example, a 20% fall in the ticket price causes an 11% rise in the quantity demanded. Therefore, the demand is inelastic. Inelastic demand is a condition in which the percentage change in quantity demanded is less than the percentage change in price. Demand is inelastic when the elasticity coefficient is less than 1. When the demand is inelastic, the drop in price overweights the increased sales, and total revenues falls from $60,000 to $500,000. Note the net change in the shaded area. Unitary elastic demand. An interesting case exists where the demand curve is either elastic or inelastic. Exhibit 1C shows a demand curve at which any percentage change in price along the curve causes an exact proportional change in the quantity demanded. When this situation occurs, the total amount of money spent on a good or service does not vary with changes in price. As the steel porcupines drop the ticket price from $30 to $20, the quantity demanded rises from $20,000 to $30,000. Therefore, using the midpoints formula, ED equals 1. And this means that every 1% change in price, there's a 1% change in the quantity demanded. For example, a 20% decrease in price brings a 20% increase in the quantity demanded. If this is the case, demand is unitary elastic, and the total revenue remains unchanged at $600,000. Unitary elastic demand is defined as a condition in which the percentage change in quantity demanded is equal to the percentage change in price. Thus, the percentage change in price equals the percentage change in quantity. Total revenue does not regard of any changes in price. Perfectly elastic demand. Two extreme cases are shown in Exhibit 2. These represent the limits between which the three demand curves explained earlier fall. Suppose the stake of the argument that a demand curve is horizontal, as shown in Exhibit 2A. At the price of $20, buyers are willing to buy as many tickets as Steel Porcupine Band is willing to offer for sale. At higher prices, buyers buy nothing. For example, at $20.01 per ticket or higher, buyers will buy 0 tickets. If so, then ED is infinity, and demand is perfectly elastic. Exhibit 2. Perfectly elastic and perfectly inelastic demand. Here, two extreme demand curves for Steel Porcupine tickets are present. Part A shows a demand curve that is horizontal line. Such a demand curve is perfectly elastic. At $20 per ticket, Steel Porcupines can sell as many concert tickets as it wish. As any price above $20, the quantity demanded falls from an infinite number to 0. Part B shows a demand curve that is a vertical line. This demand curve is perfectly inelastic. No matter what the ticket price is, the quantity demanded remains unchanged at 20,000 tickets. Perfectly elastic demand is a condition in which a small percentage change in the price brings an infinite percentage change in the quantity demanded. Perfectly inelastic demand. Exhibit 2B shows the other extreme case, which is the vertical demand curve. No matter how high or low the Steel Porcupine tickets are, the quantity demanded remains the same at 20,000 tickets. Such a demand curve is perfectly inelastic, and is ED equals 0. Perfectly inelastic demand is a condition in which the quantity demanded does not change as the price changes. Exhibit 3 summarizes the range of price elasticity of demand. Exhibit 3. Price elasticity of demand terminology. ED is greater than 1. Percentage change in quantity demanded is greater than the percentage change in price. It's elastic. ED is less than 1. Percentage change in quantity demanded is less than the percentage change in price. It's inelastic. ED equals 1. Percentage change in quantity demanded is equal to the percentage change in price. Unitary elastic. ED equals infinity. Percentage change in quantity demanded is infinite in relation to the percentage change in price. Perfectly elastic. ED equals 0. Quantity demanded does not change as the price changes. Perfectly inelastic. Am I on track? 2. Tanya notices that each time she raises the price of her lawn mowing services, the total revenue falls. We can conclude that the price elasticity of demand for lawn mowing services is A. Elastic, B. Inelastic, C. Unit elastic, or D. Perfectly elastic. 5-1C. Determinants of price elasticity of demand. Economists have estimated the price elasticity of demand for various goods and services. Exhibit 4 presents some of the estimates, and as you can see, the elasticity coefficients vary a great deal. Why do the price elasticity and demand have these products vary so much? The following factors cause these differences. 1. Availability of substitutes. 2. Share budget spent on the product. Or 3. Adjustment to a price change over time. Availability of substitutes. By far, the most important influence on price elasticity of demand is availability of substitutes. Demand becomes more elastic for a good or service when the number of close substitutes increases. If the price of cars rises, consumers can switch to close substitutes such as buses, trains, bicycles, and walking. The more public transport is to switch to available, the more responsive quantity demanded is to change in the price of cars. When consumers have limited alternatives, the demand for a good or service is more price elastic. Exhibit 4. Estimate price elastics of demand. I won't go over this. If the price of tobacco rises, people who are addicted to it have few substitutes because it's not smoking is unappealing to most users. Price elasticity also depends on how narrowly the market is undefined. The price elasticity of Toyota Camrys are greater than the price elasticity of automobiles in general because they are more close substitutes for Camrys. Other makes and models of cars, as well as any forms of transportation, then there are all cars, with other forms of transportation of substitutes. Share of budget spent on the product. When the price of salt changes, consumers pay little attention. Why should they notice? The price of salt or toothpicks can double, and the price will remain the same, a small percentage in one's budget. If, however, college tuition or house prices double, people will look for alternatives. These goods and services account for a large part of people's budgets, so they have more elastic demand. Adjustment to a price change over time. As time passes, buyers can respond fully to a change in the price of a product by finding more substitutes. Consider the demand for gasoline. In the short run, people find it hard to cut back on the amount they buy when prices rise sharply. They are accustomed to driving back and forth to work alone in their cars. The typical short-run response is to cut electricity travel and reduce speed on trips. If high prices persist over time, car buyers will find ways to cut back. They can buy cars with better fuel economy, form carpools, and ride buses or commuter trains. This explains why a short-run elasticity coefficient of gasoline exhibit 4 is more elastic at 0.34 than the long-run elasticity coefficient at 0.84. Take note, demand is more elastic when there's more close substitutes available when a large share of one's budget is spent on the product, or when there's more time available to adjust to a price change. 5-2. Price elasticity of demand along a demand curve. The price elasticity of demand, or a downward sloping line demand curve, varies as we move along the curve. Look at Exhibit 5, which shows a linear demand curve in Part A and the corresponding total revenue curve in Part B. Begin at $40 on the demand curve and move down to $35, $30, or $25, and so on. The table in Exhibit 5 lists various variations in the total revenue and elasticity coefficient, ED, at different ticket prices. If we move down the upper segment of the demand curve where ED is greater than 1, the demand is elastic, prices fall, and the total revenue rises. Recall that when the demand is elastic, the percentage change in the quantity demanded is larger than the percentage change in price. So a price decrease corresponds to a large increase in sales and overall revenue increases. At $20, price elasticity is unitary elastic. ED equals 1, and the total revenue is maximized at $400,000. As we move down the lower segment of the demand curve, price elasticity of demand falls below the value of 1. So now prices decrease correspond to small increases in sales and total revenue falls. Exhibit 5. The variation in elasticity and total revenue along the hypothetical demand curve. Part A shows a straight line demand curve and its three elasticity ranges. In $40 to $20 price range, the demand is elastic. The price decrease in this range, there is a large quantity response, and total revenue decreases. At $20, demand is unitary elastic, and the total revenue is at its maximum. Below $20, demand is inelastic. As price decreases in range, there is relatively small quantity response, and the total revenue decreases. The total revenue curve is plotted in Part B to trace its relationship to price elasticity. Take note, when demand is elastic, a decrease in price results in a relatively larger increase in the quantity sold, and the total revenue increases. When demand is inelastic, a decrease in price results in a relatively small increase in the quantity sold, and total revenue falls. It is no coincidence that the demand curve in Exhibit 5A has elastic, unitary elastic, and inelastic segments. In fact, any downward sloping straight line demand curve, has ranges of all three of the types of price elasticity of demand. As we move down from the top of the demand curve, first there is elastic range, then a unitary elastic range, and finally an elastic range. Why? Recall that the price elasticity of demand is the ratio of percentage changes. At the upper end of the demand curve, the quantities demanded are lower, and the price is higher. A change of 1 unit in the quantity demanded is a large percentage change. On the other hand, a $1 price change is a relatively small percent change. At the lower end of the curve, the situation reverses. A 1 unit change in the quantity demanded is a small percentage change, and a $1 price change is a relatively larger percent change. Exhibit 6 summarizes the relationships between elasticity, price change, and total revenue. Exhibit 6. Relationships among elasticity, price change, and total revenue. Price elasticity of demand. So we have elastic, which is ED is greater than 1, and the price would decrease, which makes the quantity larger increase, and the total revenue would increase. But if it would increase, there will be a larger decrease in the quantity, and a decrease in total revenue. Unitary elastic. ED equals 1. If there's a decrease, it would be the same increase with no change, and then the same would go for the increase. Inelastic is when ED is less than 1. If it was a decrease, then there's a smaller increase in the quantity and a decrease in total revenue. If it was an increase in price, it would be a smaller decrease in quantity and an increase in total revenue. Am I on track? 3. Consider a linear demand curve. In the top portion, where the prices are relatively high, demand is blank, and the increase in price results in a blank in total revenue. A. Elastic decrease. B. Elastic increase. C. Inelastic decrease. D. Inelastic increase. A closer look. Applying a quote concept. Price elasticity of demand. Cigarette smoking price elasticity of demand. Tobacco use is one of the chief preventable causes of death in the world. Since 1964, health warnings have been mandated in the United States on tobacco advertising, including billboards and printed advertising. In 1971, television advertising was prohibited. Many states have banned smoking in state buildings, and the federal government has restricted smoking in federal offices and military facilities. One way to curb smoking is to raise cigarette taxes. This can be especially effective in preventing teenagers from picking up the habit. Studies by Alex Ding estimate the price elasticity of demand for cigarettes for the youth to be elastic at 1.4 and for adults to be inelastic at 0.2. This means that if the price rises from 10%, cigarette consumption will fall by about 14% among the young, but only 2% among the adults. The passage of the Children's Health Insurance Program Reauthorization Act of 2009 more than doubled the cigarette tax per pack from 39 cents to 1.1 per pack. Cigarettes critics argue that this price increase would be a massive tax on lower-income Americans that would generate huge revenues to finance additional government programs about spending. In fact, proponents in part raised the cigarette tax to fund the increased cost of expanding the state children's health insurance program. In addition, proponents argued that it is not about taxes. Instead, the legislation is an attack on the death march of Americans who die early from tobacco-related diseases. Estimates of price elasticity of demand vary significantly across states, from $2 in Kentucky to 9 in Mississippi. 0.9 in Mississippi. The price elasticity of demand for cigarettes also appears to vary by education. Less educated adults are more responsive to price changes than better educated adults. This finding supports the theory that less educated people are more present-oriented or myopic than people with more education. Thus, less educated individuals tend to be more influenced by current changes in price of the pack of cigarettes. Another study in the 2000s confirmed that education has strong negative effects on the quantity of cigarettes smoked, especially in high-income individuals. The presence of young children reduces smoking, with the effect most pronounced for women. 5-3. Other elasticity measures. The elasticity concept has other applications beyond calculating the price elasticity of demand. Broadly defined, elasticity is the technique of measuring the response of one variable to changes in some other variable. 5-3a. Income elasticity of demand. Recall from Chapter 3 that the increase in income can cause a demand for a normal good or service and a decrease in demand for an inferior good or service. To measure exactly how consumption responds to changes in income, economists calculate the income elasticity of demand. Income elasticity of demand is the ratio of the percentage change in the quantity demanded of a good or service to a given percentage change in income. We use midpoints formula similar to the ones used for calculating price elasticity of demand. E1. Percentage change in quantity demanded all over percentage change in income. Where E1 is the income elasticity of demand coefficient, Q1 and Q2 represent quantities demanded before and after the income change, and I1 and I2 represent income before and after the income change. For a normal good or service, the income elasticity of demand is positive. E1 is greater than 0. Recall that this type of good, demand and income move in the same direction. Thus, the variables in the numerator and denominator change in the same direction. For an inferior good or service, the inverse is true. An income elasticity of demand is negative. E1 is less than 0. Why is the income elasticity coefficient important? Returning to our rock group example, the Steel Porcupines band needs to know the impact of recession on ticket sales. During a downturn, when consumers' incomes fall, if the rock concert is a normal good, the quantity of ticket sales falls. Conversely, if the rock concert is an inferior good, the quantity of ticket sales rises. 5-3b. Cross elasticity of demand. In Chapter 3, we learned that a change in the price of one good, Y, can cause the consumption of another good, X, to change. The responsiveness of the quantity demanded to a change in the price of some other good is estimated by the cross elasticity of demand. Cross elasticity of demand is the ratio of the percentage change in the quantity demanded for a good or service to given quantity change in the price of another good or service. Again, we use the midpoint formula as follows to compute the cross elasticity coefficient of demand. EC. Percentage change in quantity demanded of one good all over percentage change in the price of another good. Where EC is the cross elasticity coefficient, QX and QX2 represent quantities before and after the price of another good or service changes. And PY1 and PY2 represent the price of another good or service before and after the price change. The cross elasticity coefficient reveals whether a good or service is a substitute or a complement For example, suppose Coke raises its price 10%, which causes consumers to buy 5% more of Pepsi. This cross-elasticity of demand for Pepsi is positive 0.5 plus 5% all over plus 10%. Since EC is greater than 0, Coke and Pepsi are substitutes because the numerator and denominator variables change in the same direction. The larger the positive coefficient, the greater the substituency between the two goods. Now suppose there's a 50% increase in the price of motor oil, and the quantity demanded of gasoline decreases by 10%. The cross-elasticity of demand for gasoline is negative at 0.2, negative 10% all over positive 50%. The variables in the numerator and denominator change in opposite directions, since EC is less than 0. These goods are complements. The larger the negative coefficient, the greater the complementary relationship between the two goods. 5-3C. Price elasticity of supply. The price elasticity of supply closely follows the price elasticity of demand concept. Price elasticity of supply is the ratio of the percentage change in the quantity supplied of a product to the percentage change in its price. This elasticity coefficient is calculated using the following formula. ES is equal to percentage change in the quantity supplied all over percentage change in price, where ES is the price elasticity supply coefficient. Since the price and quantity supplied change in the same direction, the elasticity coefficient is a positive value. Economists use the terminology corresponding to, that is, for the price elasticity of demand. Supply is elastic when ES is greater than 1, inelastic when ES equals 1, inelastic when ES is less than 1, and perfectly elastic, expressed graphically as a horizontal supply curve when ES equals infinity, and perfectly inelastic, expressed graphically as a vertical supply curve when ES equals 0. In Chapter 8, we'll explain why this time period analysis is the primary determinant of shape of the supply curve. More specifically, it will show that the price elasticity of supply is greater in the long run than the short run. Thus, the long run supply curve will be flatter, more elastic. Exhibit 7 gives us a summary of the three elasticity concepts presented in this section. Exhibit 7. Supply of other elasticity concepts. I will not go over this. 5-4. Price elasticity and taxation. Who pays a tax levied on sellers of goods such as gasoline, cigarettes, and alcoholic beverages? One way to answer this question is to say that if the government places an exercise per unit tax on, say, gasoline, the gasoline companies pay the tax. They collect the tax when they sell the gas and write the checks to the government for the tax. But this is not the whole story. Instead of looking simply at who writes the checks, economists use the elasticity concept to analyze who really pays the tax. Tax incentive is the share of tax ultimately paid by consumers and sellers. In this section, we show that even though taxes are collected by sellers, buyers do not escape a share of the tax burden. The tax insolence depends on price elasticities of demand and supply. Let's look at two examples. Suppose the federal government decides to raise the gasoline tax by 50 cents per gallon. Exhibit 8 shows the impact of tax on different demand curves. At E1 in Part A, the equilibrium price for tax is at $3 per gallon, and the equilibrium quantity is at 30 million gallons per day. We saw in Chapter 4 the effect of the tax is to shift the supply curve upward equal to the amount of tax, which means it shifts the supply curve leftward from S1 to S2. On the seller's viewpoint, the cost per gallon of gasoline increases by 50 cents per gallon at any possible selling price. The effect is exactly the same if the price of crude oil or any resource used to produce gasoline increased. Sellers would like the consumers to pay the entire amount of tax. This would occur if consumers would pay $3.50 per gallon for the same 3 million gallons per day they purchased before the tax. But the leftward shift in the supply established a new equilibrium at E2. The new equilibrium price is at $3.25 per gallon, and the equilibrium quantity falls to 25 million gallons per day. At E2, the entire shaded area represents the tax revenue. The government collects 12.5 million per day, which equals to the 50 cents per gallon tax times the 25 million gallons sold each day. The vertical line between E2 and T represents the 50 tax per gallon. Since consumers now pay $3.25 instead of $3 per gallon, they pay one half of the tax. The sellers pay the remaining half of the tax. Now the sellers spend 50 cents to Uncle Sam and keep the $2.75 compared to $3 per gallon they kept before the tax. This example of tax insensitive is divided evenly between consumers and producers, but the price elasticity of demand or supply were different. The division may not be equal. Part B, Exhibit 9, is a special case in which the market price increases by the full amount of tax per gallon. Here, the demand for gasoline is perfectly inelastic. In this case, buyers do not decrease the quantity demanded in response to the decrease in the spikes caused by tax. The quantity demanded is 330 million gallons per day, before and after the tax. The price, however, increases from E1 to E2 by exactly the amount of the tax per unit, from $3 to $3.5 per gallon, and therefore consumers pay the entire burden of the tax. After paying the tax, sellers receive a net price of $3 per gallon. The total tax revenue collected by government is in the shaded area. Each day, 15 million is collected, which equals to the 50 cents per gallon tax multiplied by 30 million gallons sold per day. Take note that tax installments, or the share of tax ultimately paid for by consumers or producers, is determined by the price elasticity of demand and supply. Exhibit 8. The tax indulences of tax on gasoline. In parts A and B, as shown as the supply curve before the imposition of tax of 50 cents per gallon on gasoline, the tax demand curve is not affected by this tax collected from the sellers. The initial equilibrium is E1. Before the tax, the price is $3 per gallon, and 30 million gallons will be bought and sold. In Part A, the equilibrium price raises to $3.25 per gallon at E2 as a result of the tax. After the tax is paid, sellers receive only $2.75 per gallon, point T, instead of the $3 they received before the tax. Thus, buyers pay 25 cents in tax per gallon, and the sellers bear the remaining 25 cents. The shaded area is the total tax collected. As shown in Part B, a tax collected by sellers can be fully shifted to buyers only in an unlikely case that the demand is perfectly inelastic. Since the quantity of gasoline purchased is responsive to a change in the price, sellers receive $3 per gallon before and after they pay the tax. Key terms: price elasticity of demand, elastic demand, total revenue, inelastic demand, utilitarian demand, perfectly elastic demand, perfectly inelastic demand, income elasticity of demand, cost elasticity of demand, price elasticity of supply, tax indolence. Summary: price elasticity of demand is the measure of the responsiveness of the quantity demanded to the change in price. Specifically, price elasticity of demand is the ratio of the percentage change in the quantity demanded to the percentage change in price. The elasticity of demand occurs when the change in more than 1% in the quantity demanded in response to 1% change in price. Demand is elastic when the elasticity coefficient is greater than 1, and total revenue, price times quantity, varies inversely with the direction of the price change. Inelastic demand occurs when there's a change in less than 1% of quantity demanded in the response of 1% change in price. Demand is inelastic when the elasticity coefficient is less than 1, and total revenue varies directly with the direction of price change. Utilitarian elastic demand occurs when there is 1% change in the quantity demanded in response to the 1% change in price. Demand is utilitarian elastic when the elasticity coefficient equals 1, and total revenue remains constant as the price changes. Perfectly inelastic demand occurs when the quantity demanded declines to 0 for even the slightest rise or fall in price. This is an extreme case in which the demand curve is horizontal and the elasticity coefficient equals infinity. Perfectly inelastic demand occurs when the quantity demanded does not change in response to price changes. This is an extreme case in which the demand curve is vertical and elasticity coefficient equals 0. Determinants of price elasticity of demand include the availability of substitutes, the percent of one's budget spent on the product, and the length of time allowed for adjustment. Each of these factors is directly related to elasticity coefficient. Income elasticity of demand is the percentage change in the quantity demanded divided by the percentage change in income. For a normal good or service, income elasticity of demand is positive. For an inferior good or service, elasticity of demand is negative. Cross elasticity of demand is the percentage change in the quantity demanded for one product caused by the change in price of another product. the cross-elasticity of demand is positive, and the two products are substitutes. When the cross-elasticity of demand is negative, the two products are complements. When the price elasticity of supply is the measure of the responsiveness of the quantity supplied to a change in price. Price elasticity of supply is the ratio of percentage change in quantity supplied to the percentage change in price. Tax indulgences is the share in tax ultimately paid by buyers and sellers, facing a downward sloping demand curve and upward sloping supply curve. Sellers cannot raise the price by the full amount of tax. If the demand curve is vertical, sellers will raise the price by the full amount of tax. Take note, the price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. The midpoint formula for calculating the price elasticity of demand is: demand is more elastic when there is more close substitutes available, when the largest share of one's budget is spent on a product, or when there's more time available to adjust its selling price. When demand is elastic, a decrease in price results in a relatively larger increase in the quantity sold, and then total revenue increases. When demand is inelastic, the decrease in price results in a relatively small increase in the quantity sold, and then total revenue falls. The tax indulgence or sharing tax ultimately paid by consumers or producers is determined by the price elasticity of demand and supply. Study questions and problems. Please see Appendix A for answers to odd-numbered questions. Your instructor has access to the answers to the even-numbered questions. 1. If the price of a good or service increases and the total revenue received by the seller declines, is the demand for this good over the segment of demand curve elastic or inelastic? Explain. 2. Suppose the price elasticity of demand for farm products is inelastic. If the federal government wants to follow a policy of increasing income for farmers, what type of programs will the government enact? 3. Suppose the price elasticity of demand is used for used cars is estimated to be 3. What does this mean? What will affect on the quantity demanded for used cars if the price rises by 10%? 4. Consider the demand schedule. What is the price elasticity of demand between A, P of 25 and P of 20, B, P of 20 and P of 25, 15, C, P of 15, P of 10, D, P of 10 and P of 5? 5. Suppose the university raises tuition from $30,000 to $35,000. As a result, student enrollment falls from 5,000 to 4,500. Calculate the price elasticity of demand. Is the demand elastic, unitary elastic, or inelastic? 6. Will each of the following changes in price cause the total revenue to increase, decrease, or remain unchanged? A. The price falls and the demand is elastic. B. The price rises and demand is elastic. C. Price falls and the demand is unitary elastic. D. The price rises and the demand is unitary elastic. E. Price falls and demand is inelastic. F. The price rises and demand is inelastic. 7. Suppose the movie theater raises the price of popcorn by 10%, but customers do not buy any less popcorn. What does this tell you about the price elasticity of demand? What will happen to the total revenue as a result of the price increase? A. Child loves Mellow Yellow and will spend $10 per week on the product no matter what the price. What is this price elasticity of demand for Mellow Yellow? 9. Which of the following pairs of goods has the greater price elasticity of demand? A. Oranges are Sunkist oranges. B. Cars are salt. C. Foreign travel in short run or foreign travel in long run. 10. The Energizer Bunny has Keep Going and Going has a very successful ad campaign for batteries. Explain the relationship between this slogan and the firm's price elasticity of demand and total revenue. 11. Suppose the income elasticity of demand for furniture is 3, and the income elasticity of demand for physician services is 0.3. Compare the impact of furniture and physician services of a recession that reduces consumers' incomes by 10%. 12. How will you determine whether Nike and Reebok are in competition with each other? 13. Assume the cross elasticity of demand for car tires with respect to price of cars is -2. What does this tell you about the relationship between car tires and cars when the price of car rises by 10%? 14. Consider the following supply schedule. What is the price elasticity of the supply between A, P of 10 and P of 8, B, P of 8 and P of 6, C, P of 6 and P of 4, D, P of 4 and P of 2, and E, P of 2 and P of 0? What would consumers prefer the government tax products with elastic or inelastic demand? 16. Opponents of increasing the tax on gasoline argue that the big oil companies just pass the tax along to the consumer. Do you agree or disagree? Explain your answer. 17. The marketing staff at American Airlines is concerned with low sales revenues and announces special cuts in fares this summer. The New York to Los Angeles fare, for example, is reduced from $500 to $420. Does the American Airlines staff think the demand is elastic, unitary elastic, or inelastic? 18. If Congress prohibited the sales of Japanese luxury cars such as Lexus, Acura, and Infiniti in the United States, how will this affect the price elasticity of demand for Mercedes, BMWs, and Jaguars in the United States? 19. When Honda introduced the Acura to compete with European luxury cars, there was a danger that the new line would take sales away from Honda's Accord. To make a Honda more competitive with other luxury cars, suppose Honda cuts the price of the Acura while keeping the price of the Accord unchanged. If Honda's fears come true, will it find that negative cross-elasticity of demand or a positive cross-elasticity of demand? I'm going to track answers. 1C, 2A, 3B. Sample quiz. See the appendix B for answers to the sample quiz questions. 1. A perfectly elastic demand curve has a elasticity coefficient of A 0, B 1, C less than 1, D infinity. 2. If the percentage change in quantity demanded of a good is less than percentage change in price elasticity of demand is A elastic, B inelastic, C perfectly inelastic, or D unitary elastic. 3. As shown in Exhibit 9, the price elasticity of demand for good X between points A and B is A 3/7, B 7/3, C a half, or D 1. 4. Which of the following is true about the price elasticity of demand on top part of a linear demand curve? A. Demand is inelastic, B. Demand is unitary elastic, C. Demand is elastic, D. It's impossible to tell. 5. Price elasticity of demand tends to be longer in the long run than the short run. Which of the following is the reason for this that the statement is true? A. Over time, people's incomes increase. B. Over time, people find ways to adjust their behavior and find substitutes. C. Over time, the good will become smaller and smaller share of people's budgets. D. People see fewer and fewer substitutes for goods in the long run. 6. If a decrease in the price of movie tickets increases the total revenue of movie theaters, this is evidence that demand is A. Price elastic, B. Price inelastic, C. Unit elastic with respect to price, or D. Perfectly inelastic. 7. Suppose the president of the college argues that a 25% in tuition raise will raise the revenues for the college. It can be concluded that the president thinks that demand to attend this college is A. Elastic, B. Inelastic, C. Unitary elastic, or D. Perfectly elastic. 8. The president of Tucker Motors says lowering the price won't sell a single additional Tucker car. The president believes that the price elasticity of demand is A. Perfectly elastic, B. Perfectly inelastic, C. Unitary elastic, or D. Elastic. 9. If a straight line demand curve slopes down, the price elasticity will A. Remain the same at all points of the demand curve, B. Change between points along the demand curve, C. Always be greater than 1, or D. Always equal to 1. 10. Along a segment of the demand curve where the price elasticity of demand is less than 1, a decrease in the price A. is impossible, B. will increase total revenue, C. will decrease total revenue, or D. decrease the quantity demanded. 11. If Tucker University increases tuition to increase its revenue, it will A. not be successful if the demand curve slopes downwards, B. successful if demand is elastic, C. be successful if demand is inelastic, D. be successful if the supply is elastic. 12. If the price elasticity of demand is unitary elastic, then a 10% decrease in the price will result in A. a 10% increase in quantity demanded, B. a greater than 10% raise in quantity demanded, C. a less than 10% increase in the quantity demanded, or D. a decrease in the quantity demanded. 13. Connor notices that when he lowers the price of Verizon from $13 per pound to $11 per pound, sales of Verizon increase from 46 pounds per week to 50 pounds per week. The price elasticity demand for Verizon is A. 1.5, B. 1, C. 0.5, D. 0.25. 14. In Exhibit 10, the change in the total revenue resulting from a change in the price from A to D indicates that the demand curve is A. elastic, B. inelastic, C. perfectly elastic, or D. perfectly inelastic. 15. If the price elasticity of demand is elastic, then A. EUD is less than 1, B. Consumers are not very responsive to the price increase, C. An increase in the price will increase total revenue, D. There's likely a large number of substitute products available. 16. The quantity of bread demanded raises 2% when the price of bread declines 10%, then the price elasticity demand is A 0.2, B 1, C 2, D 10, E can't be determined. 17. Suppose Alice wants to buy 5 bars of chocolate of English toffee each week, regardless of whether the toffee bars are regularly priced at $1 or on sale for 50 cents. Based on this information, what is Alice's price elasticity demand for English toffee in this price range? A 0, B 1, C infinity, D can't be determined. 18. Suppose Bill's budgets exactly $50 per month for fresh shrimp, regardless of whether the shrimp is priced at $10 per pound or is on sale for $4 per pound. Based on this information, Bill's price of electricity demand is A 0, B 1, C infinite, or D can't be determined. 19. What is the price elasticity demand for the vertical demand curve? A. Perfectly inelastic, B. Inelastic but not perfectly inelastic, C. Unitarily elastic, D. Elastic but not perfectly elastic, or E. Perfectly elastic. 20. A perfectly priced demand, elastic demand, is constant with which of the following? A. A horizontal demand curve, B. Fewer close substitutes, C. Inferior goods, D. A low cross price elasticity demand. 21. If the bus travel is an inferior good, its income elasticity demand is A. Strictly greater than 1, B. Positive, C. Equal to 0, D. Negative. 22. If a good is inferior in the economic sense, A. Is a demand price elastic, B. Is a demand price inelastic, C. The income elasticity demand is negative, or D. Is a low quality good. 23. If automobiles and gasoline are complements, then their cross elasticity coefficient is A. Strictly greater than 1, B. Positive, C. Equal to 0, or D. Negative. 24. Suppose that when the price is $10, the quantity supplied is 20 units, and then when the price is 6, the quantity supplied is 12 units. What is the price elasticity of supply? A 0.5, B 0.8, C 1, and D 1.5. 25. Using supply and demand analysis, which of the following is true? The more elastic the demand curve, A. The larger portion of sales tax that is passed on the consumer, B. The smaller portion of sales tax that's passed on the consumer, C. It does not make any difference how flat the demand curve is, the tax always split evenly between the buyer and seller, D. The full tax is passed on to the consumer no matter how flat the demand curve is. And that's it.